exploration. But if you actually go back and look at historical footage of astronauts getting ready on launch day, they aren't wearing white at all. They're wearing bright orange. Okay, let's dive right into this. Why the brilliant white while they're floating around in space? And why the sudden shift to a bright, unmistakable orange during the launch? Well, it turns out it's not some random fashion choice for the cameras. It's an absolutely crucial engineering decision, and it is dictated 100% by survival. Take a look at this stark visual duality. On one side, we've got the classic white extravehicular activity suit, the EVA suit. And on the other side is the highly visible orange advanced crew escape suit. Astronauts actually affectionately call that one the pumpkin suit. Now, these aren't just different outfits. They are entirely different life support systems engineered from the ground up for completely different environments. And this brilliantly illustrates exactly when they swap these colors. It maps perfectly to the chronological arc of a standard mission. During takeoff, the crew is strapped in wearing that orange pumpkin suit. Then, once they reach orbit and actually transition to working in space, they swap over to the white EVA suits. Finally, for re-entry back to Earth, boom, they're back in the orange. It's a highly precise sequence tied directly to the specific phase of the mission. All right, let's focus on the vacuum of space first. Once you leave the Earth's protective atmosphere, an astronaut stepping outside their spacecraft is immediately exposed to the absolute thermal extremes of our solar system. It is a harsh, unforgiving place, and that is exactly where the white EVA suit goes to work. See, the primary threat up there is solar radiation. When you're in the direct, unfiltered path of the sun's rays, human beings need a highly reflective shield. The color white acts as a crucial thermal regulator. It literally reflects that intense light and heat away to keep the astronaut from overheating. Plus, it provides incredibly high visibility against the pitch black backdrop of deep space. So, to put it simply, the white EVA suit is essentially a personal, wearable spacecraft. That stark white color isn't just for show, it's its primary defense mechanism. It is a beautifully simple, yet incredibly effective way to manage the harsh reality of unfiltered solar radiation. It's basically the ultimate shield while you're floating out there in the cosmos. But what about the transition phases? When we pivot back down to Earth for takeoff and re-entry, the immediate threats shift drastically. These are highly volatile moments. During these phases, the spacecraft is interacting directly with our own planet's atmosphere and surface, and the rules of the game completely change. Because of the physical trajectories needed to safely reach orbit and then come back down, flight paths inherently place the crew over massive expanses of open ocean. Think about it. If a critical anomaly happens, say something goes wrong during launch or re-entry, astronauts might be forced to bail out or splash down unexpectedly. Suddenly, the primary hazard isn't solar radiation at all. It's getting lost at sea. So the crucial point is this. International orange is the absolute easiest color to detect in open water. That's exactly why it is the standard color for aerospace search and rescue. If a capsule has to abort into the ocean, rescue teams need to spot those astronauts instantly against all that dark, churning blue water. A white suit? Well, that would just vanish into the cresting waves and seafoam. But international orange? It stands out like a massive, highly visible distress beacon. Now, what's really interesting about this slide is seeing how the engineering completely flips based entirely on the immediate threat. The white EVA suit acts as a thermal radiation shield for the vacuum of space, right? Meanwhile, the orange ACS suit serves as a life-saving, high-visibility rescue beacon for the open water. The design logic adapts perfectly to whatever the most pressing danger is at that very specific moment in time. So, it leaves us with this thought. In the extremes of space exploration, is any color choice ever just a coincidence? Definitely not. When you're dealing with the vacuum of space and the freezing depths of the ocean, every single pigment is a highly calculated decision, where design quite literally dictates survival. So the next time you see an astronaut strapping in or floating above the Earth, you'll know exactly why they're wearing that pumpkin suit or the bright white EVA.